when the space probe began experiencing some issues and sent a bunch of code that scientists just couldn't figure out.
Unexpectedly, the NASA launched Voyager 1 spacecraft, which had a 5-year lifetime and was launched 45 years ago, has begun broadcasting cryptic binary signals from uncharted space. NASA's finest specialists have been baffled by these strange signals, despite their best efforts to reset the spacecraft. Is this bewildering data more than just an error? Come along as we attempt to interpret the enigmatic Voyager 1 communications. The unsettling data from Voyager 1 has once again piqued our curiosity with its incredible cosmic journey. Not so long ago, there was a tense moment when we almost lost contact with Voyager 1. NASA revealed a significant problem with their flight data system on December 12, 2023. Engineers were unable to decipher the bewildering binary data that the device was sending back to Earth, a series of ones and zeros. Voyager 1's returned data was gibberish, indicating a significant issue, even though the NASA crew could still transmit orders to the distant spacecraft and confirm that its systems were operating. NASA conducted a system reboot as their first line of action to try to resolve the problem. Sadly, this tactic was ineffective, and the spacecraft kept sending erroneous data. For months, NASA specialists diligently looked at several solutions to the issue. Even though their meticulous approach was fraught with errors, they never lost up on their goal of restoring the spacecraft to operational condition. They ultimately devised a workable solution, the details of which will be made public shortly. One must first comprehend the significance of Voyager 1 and the associated risks in order to really appreciate their wonderful plan. Our understanding of the solar system has changed as a result of several important discoveries made during Voyager 1's journey. One of the most astounding findings came from careful examination of Jupiter's moon Io by scientists. Contrary to early assumptions that it was a quiet, lifeless rock in space, Voyager 1 found that Io was a planet teeming with volcanic activity. Even the most seasoned NASA specialists were shocked by the sight of a volcano on Io blasting debris into space, captured in one very amazing shot. The significance of this image lay in the way it changed our perception of the dynamic processes occurring on solar system bodies. In the same vein, viewers were captivated by the incredible image that Voyager 1 captured of Saturn. Saturn's rings were shown in unprecedented detail. That was hardly the only contribution provided by Voyager 1. It was discovered that Titan, Saturn's biggest moon, had intriguing features that suggested liquid water may exist there. This finding sparked optimism for the presence of life or, at the very least, the creation of conditions that might support life elsewhere in the universe. These are some of the amazing findings that Voyager 1 made. But the latest communication issues brought to light the challenges the spaceship was encountering as it ventured farther into the unexplored region of deep space. The Voyager 1 flight data system, an essential component required for its operation, was found to be the cause of the problem. Among the many complex parts that make up this system are the main computer, data storage units, command interface, and telemetry systems. NASA experts had a great deal of difficulty attempting to resolve a bug in this intricate system. Launched in 1977, Voyager 1 has been in orbit for almost 40 years. Humanity has accessed invaluable data and images of our solar system and beyond thanks to its mission. The spacecraft's resilience and durability are proof of the scientists' and engineers' meticulous preparation and foresight. While traversing interstellar space, Voyager 1 continued to transmit data back to Earth, offering a unique glimpse into the vast expanse beyond our solar system. The newest issues with Voyager 1's flight data system threaten to break this crucial connection. The flight data system is essential to maintaining the spacecraft's functionality and guaranteeing its capacity to operate independently as it gets farther from Earth. A significant obstacle was the system's incapacity to transmit coherent data. NASA specialists had to investigate every system on board the spaceship in detail in order to pinpoint the problem and find a solution. During this troubleshooting phase, scientists spoke with Voyager 1 in a variety of ways. They analyzed the jumbled data, issued commands, waited for responses, and used every tool at their disposal to determine the root of the issue. The sophisticated flight data system and the distance, more than 14 billion miles from Earth, combined with a 20-hour communication delay in both directions, made the mission more challenging. The NASA team's perseverance and ingenuity eventually led to a breakthrough. In order to guarantee that Voyager 1 could continue sending crucial data back to Earth, they were able to circumvent the troublesome areas and restore coherent data flow by coming up with a workaround. Using redundant components in the system redesign was necessary for this strategy. The management teams and the spacecraft's resilience was shown by how successfully this patch performed. An integral component of the spacecraft's design, the flight data system of Voyager 1, is where the issue in question originated. This system organizes and processes all of the data collected during the trip. It functions as the spacecraft's central nervous system. By coordinating the activities of several subsystems, it ensures that everything functions well during the protracted trip. After several months of diligent investigation, experts are coming nearer to figuring out the error's primary cause. This thorough examination of the problem brings to light both the challenges associated with using such outdated technology in space and the extraordinary imagination and foresight of the engineers who designed Voyager over 40 years ago. The examination of the problem and the communication methods employed with Voyager 1 provide an engaging glimpse into the astounding accomplishments and constraints of the early space technology, which is being utilized to send crucial information over long distances even now. NASA engineers discovered a significant issue when they discovered that around 3% of the flight data system memory on Voyager 1 was tampered with. The damage might potentially have been caused by the outdated gear. Charged particles from outer space are most likely to blame. The team's innovative method came about since they were unable to repair the broken memory chip from Earth. The faulty code was split up and the fragments were transferred to memory locations that were not being used by the machine. Voyager 1 got the first update that tried to resolve the problem on April 18, 2024. The scientists had to wait tensely for confirmation because Earth and the spaceship were 30 billion miles away from each other round trip. The news that the upgrade had been completed brought a collective sigh of relief from NASA's control center on April 20, 2024. The next step was to reconstruct the lost code portions, which was a necessary task to ensure that the probe could begin returning to Earth to send crucial scientific data. There have been several system failures due to the hostile environment in space. Furthermore, Voyager 1 has provided vistas of Saturn and its rings that were previously unachievable. The clear images of Saturn's rings and the new information about Titan captured the attention of people all around the world. Voyager 1's suggestion that liquid water may exist on Titan's surface raises intriguing questions about the possibility of life. Given the recent failure of Voyager 1's flight data system, there are serious issues with the mission's continuation. Being the primary neurological system of Voyager 1, the flight data system is vital to the spacecraft's operation. As the spaceship moves farther into the uncharted territory of deep space, its ability to independently handle and interpret data becomes more and more important. In order to prolong the operating lifespan of Voyager 1 and 2, NASA was forced to make some tough decisions, such as shutting off heaters and other non-essential components in order to conserve energy. This conservation strategy has guaranteed the continued operation of critical parts, such as the high-gain antenna, which is required to maintain contact with Earth. Among the crucial equipment that the probes still carry are magnetometers, which are vital for studying the magnetic fields of the Sun and outer planets. In 2015, these devices produced a seminal discovery when they demonstrated that solar winds might alter magnetic fields even beyond the heliopause, the point beyond which solar influence decreases. Both Voyager spacecraft continue to utilize low-energy charged particle detectors, which were essential in identifying the heliopause following a major solar outburst in 1993. The spacecraft's hydrazine engines are still operational, so it can change its course and maintain optimal temperature. The probe's rear instruments are shielded from space dust and debris by micrometeorite shields, which further ensures the lifespan of their mission-critical components. One crucial component of the system that is still in use is the optical calibration target devices, which ensure the accuracy of the probe sensors. Because they have repeated this calibration process, which entails aligning with a target plate during their extensive journeys, their scientific data may be trusted. Because of these safety measures, Voyager 1 and 2 are still able to provide invaluable space data even after many other sensors have been switched off for decades or longer. Radioisotope thermoelectric generators, RTGs, are used by the Voyager probes to regulate their energy needs. Because these devices can convert heat from decaying plutonium-238 into electrical power, they have significantly extended mission lifespans. But the power output of these generators is gradually decreasing, and it is expected that they will eventually fail. All in all, the extraordinary space voyages of the probes may come to an end sooner than anticipated, capping off an amazing era of space research. Even after they are gone from sight, the scientific contributions made by the Voyager will endure. Voyager Golden Records are time capsules installed on every ship that are designed to impart knowledge about Earth to any intelligent alien civilization that may happen to stumble upon them. These recordings demonstrate the diversity of life and culture on Earth with a variety of musical selections, noises from our planet, and greetings in 55 different languages. The Golden Records are like a message in a bottle, encapsulating the richness of human culture as well as the intricacy of Earth's ecology. The significance of the Voyager mission goes well beyond the scientific advancements it has enabled. Thanks to Voyager 1 and 2, humanity now has access to hitherto unattainable viewpoints and data about the outer planets and the interstellar medium. As an illustration, Voyager 1 delivered the first high-resolution images of Jupiter's moon Io, demonstrating that it is the most volcanically active body in the solar system. This discovery made us reevaluate how we interpret the geological activities of heavenly worlds. Furthermore, Voyager 1's exploration of Saturn and its moons has been innovative. Titan's icy surface may contain liquid water, according to intriguing information about the planet discovered by the expedition. Additionally, it captured exact images of Saturn's rings. These findings have sparked speculation about the likelihood of extrasolar life and inspired follow-up initiatives to learn more about these fascinating possibilities, such as the Cassini-Huygens mission. The contributions of Voyager 2 are equally noteworthy. During its flybys of Uranus and Neptune, it acquired the first close-up images of these distant giants and discovered several new moons in addition to complex ring systems and atmospheric processes. Voyager 2's investigations of Triton, Neptune's moon, revealed the potential of underground seas with its nitrogen gas geysers, expanding the spectrum of conceivable alien habitats. The constant study of the data returned by the Voyagers yields new discoveries on a regular basis. For instance, recent studies on interstellar space have shed light on the properties of cosmic rays and the interstellar medium, which has increased our understanding of the environment that exists outside of the influence of our Sun. According to data from Voyager 1, the Voyager missions have had a significant impact on the public's creativity and imagination. Apart from their scientific achievements, Voyager 1 was requested by astronomer Carl Sagan to take the iconic pale blue dot picture, which shows Earth as a tiny dot in the vastness of space. Over time, this image has come to symbolize both the vulnerability of our planet and the interdependence of all life on Earth. The Voyager Golden Records, humanity's message to the universe, remain a symbol of our insatiable curiosity and drive to discover new things. They remind us that we will never know everything there is to know about the cosmos, even as they quietly travel across the vastness of space. Among the most identifiable elements of the Voyager missions are the Golden Records. They are time capsules designed to preserve information about Earth's past for any sentient extraterrestrial species that might come into touch with them. Rather than being only scientific relics, the Golden Records represent a cultural message in a bottle tossed into the cosmic ocean. Each record contains 116 analog encoded photos that illustrate many aspects of life on Earth, such as daily living, the variety of human civilization, and the unique features of our planet. These images provide a glimpse into our reality. The pictures, which show anything from serene countryside to bustling cities, encapsulate the essence of the world and entice everyone who stumbles onto the archives to discover more about the planet from whence they came. It resembles a handshake that is extended into space. This massive endeavor reflects humanity's profound yearning to connect and communicate across the vastness of space. It symbolizes our dream that one day a highly advanced society would be able to identify these earthly echoes and discern a connection to a distant blue planet orbiting a shared star. The Golden Records are a real-life illustration of the human spirit's continuous quest for information, comprehension, and discovery. Earth sounds are also featured in the album's audio sections, which contribute to its rich oral atmosphere. These sounds, which depict the vibrancy of life on Earth, span from wind and thunder to human heartbeats. They offer a visceral experience. The albums aim to provide listeners with a deeper understanding of life on Earth than just a visual representation by including these sounds. Additionally, by incorporating a broad variety of music from many countries and times, the Golden Records highlight the richness of human creativity and culture. Every musical genre, from classical compositions to international folk melodies, reflects the range of human emotion and artistic expression. This musical collection aims to show how music is a universal language that cuts over linguistic and cultural barriers. These golden recordings are floating in space, waiting to be discovered by someone. They may contain the last words of mankind, as they carry a fragment of our planet with them. Unlike regular vinyl records, these ones were constructed of robust copper and were gold-plated to withstand the severe temperatures seen in space. This meticulous design will ensure that the information in the records is kept safe for a very long time. It may last for billions of years. To make sure that any sentient entities who find the records can understand the message, the records also carry instructions inscribed on their surfaces in the world languages of science and mathematics in addition to English. The construction of a stylus and cartridge to play the records is explained in these instructions. This thorough preparation demonstrates how concerned NASA was to make sure that researchers in the future could understand these recordings. In addition to the audio and visual components, the recordings include greetings in 55 different languages, which are Earth's way of extending a cordial invitation to any prospective extraterrestrial civilizations. These greetings, which span from ancient to contemporary dialects, represent the diversity of languages spoken around the world. This section of the archives demonstrates our desire to establish contact and have a conversation with any potential cosmic neighbors. The Golden Records also include a wealth of scientific information, including diagrams showing the structure of DNA, human anatomy, and basic concepts in physics and mathematics. This is intended to provide prospective alien discoverers with a fundamental understanding of our species and our understanding of the universe. By sharing this scientific information, the records seek to promote a spirit of collaborative research and discovery. The recordings also contain a range of human-produced sounds, such as the boom of a rocket launch, the buzz of a spaceship, and the mechanical noises of Earth's technology. These sound recordings demonstrate the distinctions between the sounds of the natural and artificial worlds while also providing a window into our technical capabilities. The range of characteristics found on the Golden Record demonstrates the inventiveness and progressiveness of the scientists and artists who created it. Their goal was to depict the breadth and depth of the human experience in order to provide a nuanced portrait of life on Earth. The human intelligence, inventiveness, and continuous pursuit of communication with intelligent species outside our solar system are all still inspired by the Golden Records. Future space exploration, problems left by the Voyager probes, and their continuing journey into the interstellar gap. A chart displaying the Sun's location in relation to 14 pulsars may be found in one of the Golden Records discovered on board the Voyager probe. The exact and consistent radiation emissions from these pulsars make them universal markers. These pulsars serve as markers for Earth's location inside the Milky Way, as seen in the picture. This innovative idea aimed to reach out to potential alien civilizations and offer assistance. But there is a price to this cosmic diplomacy. By providing a map of Earth, we can unwittingly draw in extraterrestrial visitors with less than kind motives, which could spark hostilities. This concern was significant, but it did not overshadow the Golden Record's primary goals, which were to promote goodwill among people and showcase the diversity of life and culture on Earth. The flight data subsystem of Voyager 1 began transmitting garbled data, signifying a communication issue. At this moment, Voyager 1 is around 15 billion miles away from Earth. Engineers carefully examined the data and discovered that it included a complete memory readout from the subsystem. This information provided critical clues to them about how to solve the issue. Despite the enormous distance causing a 22.5-hour one-way delay in signal transit, the technical team managed to devise a workaround. This highlights how challenging and inventive it must be to maintain communication with spacecraft that are moving over such vast distances. Around 12 billion miles away, Voyager 2 is still in operation, with every system operating as it should. Variations in voltage may have led to power issues and put the equipment in risk. The engineers on board the spacecraft successfully utilized a little reserve of power from the radioisotope thermoelectric generator to ensure the scientific equipment remain operational. Like a delicate tango between space physics and human effort, this meticulous power management balance illustrates how careful planning and innovation are required to enable long-term space missions. To stay in contact with the Voyager spacecraft, mission control needs to perform exact calculations and adjustments. The distance between Earth and the Voyager spacecraft decreases over short periods of time as Earth approaches both of them at a speed of 67,000 miles per hour. Rather than shifts in the spacecraft's paths, this phenomena is produced by Earth's changing orbital path. The continuous Voyager missions not only provide scientific data but also act as a constant source of inspiration, demonstrating the incredible things that can be achieved when curiosity and state-of-the-art technology come together. Each letter from these remote explorers offers new insights and is a poignant reminder of how little humanity is in the greater scheme of things. The length and accomplishment of the Voyager missions have spurred significant technical advancements. These days, autonomous systems on spacecraft are able to make choices without rapid input from Earth, which is essential for long-term missions that travel great distances from Earth. In order to efficiently convey data across great distances, new communication techniques are also being developed. As a lead-up to trips to Mars, efforts are in motion to return humans to the Moon and create a permanent base there. NASA has ambitious objectives, as do its foreign partners. The EMIS program is one of these initiatives. The Mars Sample Return Mission, a joint venture between NASA and ESA, intends to collect and return Martian rock and soil samples in order to ascertain whether or not life has ever existed on the planet. In addition to these journeys, NASA has been working on innovative propulsion systems that might reduce the time required to go to distant locations. One such project is the Space Launch System, SLS, which aims to be the most powerful rocket ever built, capable of carrying cargo and people beyond low Earth orbit to destinations such as asteroids, the Moon, and Mars. Innovative propulsion technologies, including as ion propulsion, have the potential to revolutionize space travel by providing more efficient and rapid means to investigate the solar system. The importance of international collaboration in space exploration cannot be overstated. The International Space Station, ISS, is a prime example of what occurs when countries work together to achieve a shared goal. Since it began to be continuously inhabited in 2000, the International Space Station, ISS, has produced invaluable data on the long-term effects of living in space and acted as a testbed for technologies that will be critical for upcoming deep space missions. Astrobiology, the study of life in the universe, has become a significant field of study for scientists. Initiatives such as the James Webb Space Telescope, designed to track exoplanet atmospheres, and the Europa Clipper, designed to investigate Jupiter's moon Europa's habitability, are at the forefront of this exciting field. These missions aim to offer basic explanations for the existence of alien life and the conditions that may support it. Furthermore, planetary defense is becoming more and more important. Double Asteroid Redirection Test, DART, is a NASA initiative designed to test our ability to reroute potentially hazardous asteroids away from Earth in order to shield the planet from future strikes. It is imperative that this expedition and further cataloging and observation of near-Earth objects, NEOs, take place. Another facet of space travel in the future is the potential for human colonization of other worlds. Sustainable resource utilization, radiation protection, and improved life support systems are now being developed. A key component of these initiatives is the idea of in situ resource utilization, ISRU, or using locally accessible resources to support human activities, as shown in the concept houses for the Moon and Mars. For example, producing oxygen from the Martian atmosphere or extracting water from the lunar regolith might significantly reduce the amount of resources that need to be transported from Earth. Commercial spaceflight is another developing sector, with private companies like SpaceX, Boeing, and Blue Origin becoming major players. To cut costs and broaden access to space travel, these companies are developing new launch vehicles and spacecraft. SpaceX's Starship, designed for flights to Mars and beyond, is a significant step toward achieving these goals. Though there are challenges due to outdated equipment and the harsh environment of space, the Voyager missions have imparted invaluable knowledge. These interactions have enhanced data management and error correction systems, enabling the next missions to address unforeseen issues. Future generations of space scientists and engineers are still motivated by the inventiveness and problem-solving skills of the Voyager engineers. Finding alien life is one of space exploration's most interesting directions. The goal of missions to Europa and Enceladus, two of Jupiter's and Saturn's icy moons, is to locate liquid water and potential habitable environments. These moons are assumed to possess the essential elements for life due to their internal heat sources and potentially nutrient-rich seas. However, how to strike a balance between space exploration and solving Earth's issues remains a key challenge. While the pursuit of knowledge and novel discoveries propels space missions, ethical considerations must also be carefully considered. The potential for Earth-based germs to spread to other worlds and the allocation of resources are two important challenges. Furthermore, the possibility of discovering extraterrestrial life raises important philosophical queries about our place in the universe and our duties as explorers. Public funding and interest are vital for space mission maintenance. Most importantly, educational initiatives and activities inspire the upcoming generation of scientists and engineers. The public may be kept informed and excited about space exploration through media, public outreach, and collaborative projects, all of which can serve to ensure continued support for the next missions. NASA's Artemis mission, for example, has created a significant deal of public interest through compelling storylines. The mission aims to return humans to the Moon and establish a permanent presence there. This initiative, which is seen as a springboard for the next Mars missions, has encouraged participation from the private sector and international collaboration. Not only may space missions inspire people, but they also have practical benefits. Technological advancements intended for space exploration occasionally find applications on Earth that improve our quality of life, such communication, weather forecasting, and disaster management. Examples of the wide-ranging benefits of space exploration include how satellite technology has revolutionized space research and led to advancements in robotics, materials science, and medical technologies. Additionally, space exploration fosters international collaboration. The International Space Station is a prime example of what can be achieved when nations work together to achieve a common goal. Other programs, such as the Mars Sample Return Mission, which is a collaborative endeavor between NASA and the European Space Agency to bring back Martian rock and soil samples to Earth, are also influenced by this cooperative spirit. These kinds of collaborations foster scientific discovery and enhance peaceful international collaboration. While others argue that funding ought to go towards solving pressing issues on Earth, it's critical to realize that space exploration and earthly issues are not antagonistic. The development of space technologies directly helps Earth. Understanding the universe may provide new perspectives on the issues affecting our planet. Pursuing these two objectives at the same time will enable humanity to continue expanding its knowledge base and address global issues more skillfully. That's all the information we have for you today. Share your opinions in the comments below. Thanks for watching another episode. While you're here, you can watch more space-related video.